We'll be looking at a new feature added with MPP firmware 12.0.7. The specific item is going to be support for custom device certificate with 802.1x type of deployments. In this video, I'll be focusing on manual installation by uploading the .p12 or .pfx certificate from the phone's administration webpage. A key item to keep in mind is most of the steps I'll be doing is before the phone is actually registered or onboarded to WebEx Calling, because I'll need access to the administration webpage where it offers the uploading of the custom certificate. There's another option which I will not focus in this video, and that's if you're doing a larger scale deployment and you're trying to leverage the SEP or Simple Certificate Enrollment Protocol server. And then, as mentioned, a lot of the initial steps will be done while the phone is not deployed or onboarded to WebEx Calling yet, because I need access to the admin web page, which is not offered once the phone is onboarded to WebEx Calling. So before the onboarding of the phone to WebEx Calling, by accessing the administration web page of the phone as an admin, we can check the installation status of the certificate, we can view the details of the installed certificate, and we can remove the installed certificate. And this is really focused on the custom certificate, so we're not going to be changing or modifying the MIC or the manufactured install certificate. And then also in the phone's configuration, we need to tell it by default it is the MIC or the manufactured install certificate. We'll be changing it to custom install certificate, and also we're going to be enabling 802.1x on the phone itself. This is the test lab environment I'm using. I have an ICE 3.4 server. It is going to be at IP address 1.95. I have a CAT 1300 switch. It'll be at address 1.93. This will be my internet access so the phone can get out and get to WebEx Calling. So this will be kind of the end stage of our testing. And then this is just kind of a screenshot of ICE as far as the live logs and what we should be seeing, once we get everything in a working state with the 802.1x authentication and the phone being able to access the network. So this is going to be very critical, the sequence of steps of how we do this. And so the first thing we need to start off with is firmware 12.07 or higher, MPP, also known as 3PCC. This is where the custom certificate feature is offered. As of the recording of this video, this is the firmware that Cloud Upgrader is using at this point of time. So if you're accustomed to using Cloud Upgrader for firmware migrations, firmware updates, the good news is, as of the recording of this video, Cloud Upgrader is using firmware 12.0.7. So this will be kind of step one or phase one. Then on the second step or second phase, if you will, we're going to load the custom certificate, also known as local significant certificate, onto the phone. We do need to do this through the phone admin access, because this exposes the certificate settings, and then we can upload and select the custom certificate. As I mentioned, the phone admin access is not offered once the phone is onboarded to WebEx Calling. So we need to make sure we take care of this step of uploading the custom certificate before there's any onboarding to WebEx Calling of the phone. And this is kind of where I have this marked here as red, so very, very critical. Step 3 is we're going to test the 802.1x EAP TLS to ensure the 3PCC phone is able to access the network. And this is before I'm onboarding the phone. So I want to make sure everything from a 802.1x custom certificate, radius server, in this case ICE, the switch, everything is functioning 100% correct before I onboarded the phone to WebEx Calling. Once I onboard the phone to WebEx Calling, if I need to do any type of certificate checking or changing, which normally I would be using the admin web page of the phone, that no longer is an option to leverage. So very critical, do this testing before onboarding the phone to WebEx Calling to make sure all the mechanics of the radius server, in this case ICE, of the switch configured as a radius client, if you will, and then the actual 802.1x device, in this case the phone, that everything is functioning correctly. Also, what I like to do is during the testing phase, I like to monitor the console output of the switch, because this will in real time tell us exactly what is occurring from a switch standpoint during the 802.1x authentication. Also, the ICE operations live logs. This also shows us from ICE standpoint what is happening, and it is fairly detailed. And I also like to take a Wireshark capture on a switch port where the phone connects to the network, and also another Wireshark capture on a switch port where the radius server packets need to pass through to get from the switch to the ICE server. And this may seem a little bit excessive, but there's two benefits of it. One is if it is not functioning, you'll pretty much immediately be able to guide yourself towards a direction of where the problem most likely is at with this much visibility. Number two, if it does work correctly, then this is items you want to save in your archive. So let's say 2 years from now you have issues, you have quite a bit of evidence what the deployment looked like in a working scenario. And then if you do the same type of capture at a future date, if you have issues, you'll be able to very quickly narrow down and pinpoint exactly what is causing issues. So again, step 3, I highly encourage that all this data is captured during testing. It's good evidence, and it's also good exercise if you do run into an issue to pinpoint exactly what might be the issue. And then the last step, or the last phase, number 4, is onboarding the 3PCC phone to WebEx Calling via activation code or via MAC address. So it's really up to you, whatever you think might be the best for your situation during the deployment phase of the phone. So we want to make sure we enable 802.1x in the WebEx control hub for the phone before enabling 802.x on a switch. Otherwise, the phone will not be able to onboard and get its configuration from WebEx Calling. So a lot of these steps, other than the testing, we want to either move the phone to a port that does not have 802.1x enabled, just so we have access to the phone and we can do all the different operations I'll show, or we want to temporarily disable 802.1x on the respective port where the phone's plugged in again, so we can do a lot of the steps I'm showing here. And then we'll go ahead and enable it during the testing phase, and then we're going to disable it so the phone can go ahead and onboard to WebEx Calling, get the config, and we're going to enable it again. So there's a number of different steps. Again, the sequence of these steps is very critical. And then within a phase 4 or step 4, we're going to enter in the WebEx Calling activation code into the phone's LCD screen. Or if we're going to do the MAC address, then we're going to enter in the MAC address of the phone in Control Hub. And then if we're using the MAC address method of adding the phone to WebEx Control Hub, then we need to do a shut to no shutdown on this respective switch port where the phone is located. Or if you're there local, you can simply unplug the phone for a few seconds, plug it back in, and that'll basically reboot the phone so you can reach out to the cloud and pull down its configuration. And this just kind of shows a high-level illustration of what I mentioned during the testing and or validation troubleshooting. So if everything works, this is just data you're going to put in your archive. So we're going to do a Wireshark capture on the switch port where it's headed towards the ICE server, so we can see our radius packets right here during the testing or troubleshooting phase. We're going to do another Wireshark capture on the switch port where the phone plugs in, and then we're going to do a live console connection to the switch. So while we're doing this, we can see exactly what's happening in real time as far as the output to the switch. And at the same time, we're going to be looking at the ICE operations live logs. So all of these vector points give us quite a lot of data. So if we do have any issues, this should be able to fairly quickly guide us to what perhaps is causing an issue. If we don't have any issues, great. We're just going to save this in our archives so at a future date, if we have any issues, we have evidence of what a working configuration looks like. And then the switch configuration I'm using is very simple. The Catalyst 1300 switches are designed to be very easy to be used. They have both an extensive web interface and also a command line interface. I factory defaulted a switch and I put the very minimum that's needed to do this type of operation that you can use as a reference. So basically I have the .1x system auth configured. I have the encrypted radius server key. So this is like a shared key between the Radius server and also the switch. And then I have the Radius server host IP address and also the key. And then I'm stating usage.1x. And then for the respective port, I have .1x port control auto. So this is basically when you plug in this case, a phone, or if it was a other device, it's going to go ahead and want to do the 802.1x TLS authentication. And then as of the recording of this video, this is the most current firmware offered on this switch. So again, this is the CAT 1300 switch, this specific model I have. This is made really for folks that may not be big experts at iOS and they want a switch that offers a lot of features, cost effective, and has a web interface and also command line. So you can go ahead and do a lot of the operations as offered with some of the higher end switches. And then I'm just going to show what it looks like in the web interface. So initially I showed you the command line. We're just going to briefly now look at the web interface, what is equivalent to what I showed you in the command line. So under security and then Radius client, so the switch is acting as a Radius client and the Radius server is ICE. So we're going to make sure that port-based access control, 802.1x, MAC-based web auth, so this is enabled. And then we're going to go ahead and type in our key string, our secret, if you will. So this needs to match both here. So one thing to note is you typically input this in plain text, but once you input and you apply, it'll flip it up to encrypted. That's why you're seeing this encrypted. But during the configuration, you're going to do plain text. You're going to type in the shared secret. So this string needs to also match what is in ICE, your Radius server, if you will. Okay, so the next one we're going to go down to is going to be the actual Radius server itself. So at the very bottom here, you'll notice we have the IP address of ICE, 192.168.1.185. This is the shared secret. These are the standard ports, 1812, 1813, and then the usage type will be 802.1x. And then I'm just showing if I go into the actual Radius server page where you go to normally configure what it looks like, the different fields. Priority, this is if I had multiple Radius servers. You can go ahead and give different priorities, 0 to 65,000, different prioritization. As far as the shared secret, plain text, you define it here, and then once you apply it, it'll bump it up and it'll only show the encrypted version, which is fine. And so these ports will leave default. So this is the default ports used for Radius. And we're interested in 802.1x, so that's kind of what I have selected at the bottom. And now we're under the 802.1x properties here. So we're going to enable port-based authentication, and we're going to be using Radius. And then we're going to do immediate for timeout, and then I have it enabled for VLAN 1. So I just have one VLAN, simplest possible example here. And then this will be the port we're going to be testing with. It will be gigabit 2. This was a screenshot I took actually once I did some initial testing that was functioning. So you can see the port has been authorized and then it's also been authenticated. So this is kind of the end result, what you should be seeing. But we'll take a look at the steps that are needed to get to this point. During the phases where we do not want to have 802.1x enabled yet on a port, we can force the authorization. So this would allow the phone to access the network temporarily while we're getting it configured, uploading the custom certificate, and or towards a later phase where the phone has to reach out to WebEx Calling, pull down its config, and get itself prepped. Then we can bounce this up to auto, and then it's going to basically start doing the 802.1x. The other method is just by disabling this temporarily, where it says 802.1x base authentication. So it's really up to your discretion which method you want to use here. But just be aware this is going to be integrated kind of in some of the steps we're going to be doing here in a few moments. Okay, there's nothing special at the bottom here we need to look at. Okay, so now we're inside of ICE 3.4 server, and we're under administration, and we're here under network devices and then network devices section. So this is the CAT 1300 switch we're just looking at. So it is at IP address .193. Then we're going to go ahead and take a look at the settings I use. So basically the label of the switch, description, IP address of the switch, it's a Cisco device, Model, it's a CAT 1300. And then if we kind of go down the page here, we're going to be using radius. This is the shared secret I was mentioning a few moments ago, where we type it in as plain text into the switch. We just want to make sure whatever string you're using here is matching between what's in the switch configuration and what's also here in ICE. And then let me see if there's anything else here. So we're going to go to the next page. Yeah, and that's, so there's not much that I'm doing here. I'm keeping stuff as simple as possible. And goal of this video is to kind of get you up and running with a very, very basic scenario, at which point you can customize on top of that based upon your configuration deployment requirements. And also what I'm doing, I'm just leveraging the default policy. So I'm not doing anything with these other policies, which I was testing something else with. So keeping everything as simple as possible. So I'm under policy and then policy sets. So I'm just using the default policy. And if you notice, here's the hit rate. So everything I'm testing with here, just going through the default policy. So this is a section that it's very critical that this is done correctly. Otherwise, EAP TLS is not going to work correctly. So in my case, since this is a lab deployment, I'm going to do a self-signed certificate. So I'm here under Administration, Certificates, System Certificates, and I'm going to generate a self-signed certificate. So I'm just going to call it ICE 34 for 3.4. And then I'm just going to put kind of my lab information in here. Again, you would be putting in whatever is appropriate for your deployment. And then this is going to be the IP address of the ICE server. Okay, I'm just going to keep this as default. I bumped this up to 10 years. Again, this is a lab environment production. Typically, you don't want to do that many years, but in any case, lab environment, my lab cert 195. Okay, and then we're going to make sure that this is going to be EAP authentication. So we want to make sure that's checked off. Okay, and then I'm basically going to hit submit right here. Okay. And then we're going to just do yes right here. Okay, and we have our certificate. So we did a self-signed certificate right here. Okay, so what we want to do right now is we want to go ahead and export this. So I'm going to go ahead and check marks this. We're going to do export. Okay, we're going to type in a private key. So you want to make sure you document this private key. We'll need to use this here in a few moments. We're going to hit export. Okay. So I just went ahead and exported this to my computer. So this is called mylabcert195.zip. And I went ahead and I unzipped that certificate. And there's two files. There's a PEM extension file and there's a private key extension file. However, if you look at the phone, so right now I am logged in as admin to the phone. You see user login because we're ready admin and also have advanced clicked. So we're here under certificate, custom, but the key thing is the phone is looking for a .p12 or .pfx. If you notice, I do not have a .p12 or .pfx. We're going to have to do a conversion. So what I'm going to use for the conversion will be Linux. And what we're going to be doing is we're going to be using OpenSSL. A couple things to note is what I noticed is the extension file name, the private key, the .pvk, I ended up changing that to .key. OpenSSL wasn't liking the .pvk extension. So this is, I'm showing what worked for me when I was doing this testing at the recording of this video. So OpenSSL, then we did the PKCS12. We're going to do an export out, mylabcert195.pfx. Okay, we're going to do this this in key, and then we're going to do the labcert195.key in mylabcert.pim. And then we're going to need to type in that password that I mentioned earlier right here when we were doing the exporting of the, or generating / exporting of the self-signed certificate. And then what you're going to notice here is going to be the PFX extension. So this is one of the extensions that the file supports for uploading as far as custom certificate. The phone supports for uploading as a custom certificate. So this is basically the step needed to convert the needed file format for the certificate for the phone to be able to ingest it. So at this point I'm going to hit browse. Again, web interface of the phone is admin access. And then we're going to find that on the actual hard drive. We're going to hit open. Okay. And then we're going to need to go type in the password we created a few moments ago in ICE when we were exporting the certificate. And we're going to submit all changes. Okay. It says certificate added. Okay. We'll hit OK here. And then I like to verify it whenever possible. So I want to take a look at it just to make sure it makes sense. Okay. So yeah, so this is definitely, it's my ICE 3.4 server. That's correct. And then this is the domain name, myhomelab.local. That's correct. Okay. And this is the location. Yep. That all looks correct. And this is the date range, 10 years. Again, this is a lab environment production. You would not be doing this many years typically. Okay. We're going to hit OK. Okay, and then we're going to go into voice. So we want to now validate this is actually functioning before we even attempt to onboard the phone to WebEx Calling. So we need to enable 802.1x right on the phone. So we're going to do that by going to Voice tab. Okay, and then we're going to go to the System tab. And then we're going to go almost to the very bottom. So if you notice the vertical scroll bar, we're almost at the bottom. 802.1x authentication. We're going to go ahead and enable this. And then we're going to submit all changes. Okay, takes a few seconds for it to adjust. Okay, and just pointing out, this is only possible if the phone has firmware 12.0.7 or higher MPP firmware. So key note, and again, we're doing this with admin access to the phone. So this would not be possible if the phone's already registered to WebEx Calling. Two key takeaways to keep in mind. Okay, so I ran into an issue. It says authentication failed. eTLS failed SSL TLS handshake because of an unknown C in the client certificate chain. Okay, so what went wrong? As I mentioned, I was analyzing this from a couple different angle points, and immediately what I realized is I forgot to do one step before testing the phone. Also, footnote, I did enable this point, the 802.1x, on the switch port where the phone is. So the actual switch challenges the phone with 802.1x, authorization, authentication, etc. So what I forgot to do in ICE was, although I created a self-signed certificate, I exported it, I converted to write format, and uploaded it to the phone. What I did not do is I did not import that self-signed certificate that was created with ICE to the trusted certificate on the ICE server itself. So what I ended up doing here was I went ahead to certificates back in ICE, trusted certificates, import, and then I went ahead and imported the certificate. If we look towards the bottom, we're going to notice here we have the MyLab Cert 195, and then this is the certificate we created a few moments ago here. And one key thing is when you're troubleshooting, looking at the serial number of the certificate and the other information, because generally somebody's using the same type of nomenclature for the certificates. A combination of the naming of the certificate with the serial number will kind of give you an idea if we're working with the right certificate. But in any case, let me go back one. The serial number of the certificate typically is a key item to look at. So now basically that I have that configured, I bounced the switch port so the phone can go in and start the 802.1x authentication. If you notice now it's green. So we've authenticated here, and then I'm going to check here the latest here. So I'm going to click on its details. And then it shows here that it authenticated succeeded. Okay, so authenticated succeeded. And this section within ICE, the live logging, is really good to take screenshots, because one is if it's working, you want to take that as evidence. So later, if you run into any issues, you kind of have evidence exactly what it should look like. So we're using eTLS. We have the CAT 1300 switch. This is the actual IP address of the network access device, if you will. And then this is the port I'm plugging my phone, which is gigabit 1/02. And then if we kind of continue down here, we'll kind of see here, this is the serial number of the actual certificate. If we're having issues certificate, I like to kind of use that as one of my vector points. We're doing .1x, authentication passed. Okay, let me see if there's anything else here. Okay, so this is kind of my information that I put in a certificate here. And then see authentication passed, eTLS authentication succeeded. Okay, so let's continue going down here. And then, yeah, so this is kind of at the very end here, accepted. So this is kind of what we should see in a working scenario. So let's continue going down here. So this point of time, we're ready for the onboarding to WebEx Calling. So what we need to do right now is we need to temporarily disable 802.1x on the switch port. And then what we want to do is we want to go ahead and add the phone to WebEx Calling. So we're going to add the phone to WebEx Calling. It could be a user or it can be a workplace. And then we can either do it via MAC address or we can do it via activation code. It's up to you as far as your discretion goes. So before I do that, I'm just going to check this one more time. At this point of time, I've done quite a lot of different testing. But before I lose my admin access to the phone, I just want to take another peek at the actual custom certificates, where it's certificate, custom, and then existing certificates. We're going to take a peek here. Again, this is only available via the admin access. So before we onboard, let's just take a quick peek. Okay, yeah, so this is definitely the certificate we created a few moments ago. Okay, so we're going to hit OK here. So at this point of time, I've added the phone to WebEx Calling. I went ahead and I did actually a couple different tests. I did testing using the activation code. It worked just fine, no issues whatsoever. I also did testing with using the MAC address. The biggest difference is if you do use the MAC address, you do need to bounce the switchboard, shutdown, no shutdown, so the phone reboots and it can do a handshake with the cloud to start the onboarding process. Okay, so again, we succeeded on the authentication here, so that all looks good. And then we'll kind of go down to the next section. Okay, so we know we are using our CAT 1300 here, eTLS.1x. Okay, so let's continue going down here. This is the serial number of the certificate. Again, we're troubleshooting. This is one of the key vector points to look at. Okay, so let me see if there's anything. And then again, this is my lab information. Okay, so let's go over here. And then towards the very end here, we have return access accepted. So it's authenticated 9 times. There's a period of time that will go ahead and kind of do a re-authentication, if you will. But everything is A-OK here, which is great. Okay, so let's continue going here. So during this whole testing deployment phase, one of the key items is going to be basically under operations in ICE. We want to go into the live logs here, and we just want to take a look at it. If you notice, I have mine set to refresh every 10 seconds. I find this kind of a good medium if I'm just doing kind of quick testing. If you have a large production environment, you probably want to put a different type of time set here. But for a small lab environment, this works very well. So I'll automatically refresh this. So you can have a couple of wire sharks going on, as I mentioned, one on a switch port where the phone is at, one on a switch port that is upstream towards a Radius server. We have also console connection to the switch, so we can see what the console is outputting. And also we have this. By having all 4 different vector points, that gives you a lot of visibility if you're doing initial proof of concept. If there's anything that hiccups, you'll be able to ID it very quickly to kind of understand what direction from a troubleshooting standpoint you can head towards. Okay, kind of the same stuff again. Okay, so we know, so this is me kind of doing the test initially with the activation code, doing another test with the MAC address, as I mentioned, and we'll just kind of continue going down. So this is what the Wireshark capture should look like. So towards the very end of the 802.1x authentication authorization, you'll see here access accepted coming from the Radius server, and that's at which point the phone actually has capability of gaining access to the network and onboarding to WebEx Calling. And then this is on control of what it looks like. So this was a 7841 phone. If you notice, it's online. You notice it's registered here. So this is a SIP stack. So it shows a little reg right here. Online right here is going to be really kind of the WebEx aware. So being able to manage a phone, getting statistics, that type of information. Again, very critical. The phone must be 12.0 or 7 or higher firmware. As of the recording of this video, 12.0.7 is the current firmware. If you have firmware below this, what I'm showing you here is not offered. Basically, it's not possible. And then what I want to point out, so the only really thing I did in WebEx Calling, other than adding the phone to Control Hub, is you need to make sure enable 802.1x. Because if you do everything else correctly, and you don't have 802.1x enabled, this will not function correctly. So make sure you enable 802.1x, get the phone to onboard to WebEx Calling. Once it has a custom certificate, you're going to temporarily need to disable 802.1x on the respective switch port where the phone is at. Let it do its onboarding, handshaking, getting the config. Then you can enable 802.1x on the respective switch port it's at. So what does it look like on the actual phone itself? So if we go under the networking section of the phone, there's a transaction status section under the 802.1x authentication. And then what we'll notice here is it shows it's using a custom installed certificate. And then the transaction status is authenticated. And then the protocol is EAP TLS. And let me see here. Okay, so there's 2 certificates on it. In this case, I am using the custom installed certificate, which is often what most folks tend to gravitate towards. They want to use their own internal custom certificates for higher level security. So as we wrap up this video, kind of just highlights, you must have version 12.0 or higher for the MPP firmware, also known as 3PCC, to be able to leverage the custom certificate for 802.1x, so that's needed. Number 2, a lot of the steps that I show in this video were done before the phone was onboarded to WebEx Calling. Why? Because once the phone is onboarded to WebEx Calling, we no longer have access to the admin page, so keep that in mind, the sequence of whence you do. And then even once we get the custom certificate, we want to validate that everything's functioning before the phone is even onboarded to WebEx Calling. Because once we onboard it to WebEx Calling, we lose admin access to the phone. So my suggestion is make sure everything's working A-OK, and then from 802.1x standpoint, the Radius server, the switch, and the phone, you feel confident, you've done the test a couple different times, unplug, plug the phone in, everything looks like it's 100% solid, and that's the phase you want to go ahead and onboard it to WebEx Calling. So temporarily, you'll disable 802.1x in a switch, add the phone to WebEx Calling, and then to start the onboarding process, let it do the onboarding. That will take a couple minutes. Once it's onboarded, it looks like it's stabilized. Then you want to go ahead and enable 802.1x, unplug the phone, plug it back into the respective switch port, and then go ahead and test the authentication. Make sure everything looks good in Radius server, ICE server in this case. Everything looks good at switch standpoint. Kind of the pattern of what I mentioned, those 4 vector points. Wireshark capture in the switch port where the phone is, Wireshark capture in the uplink port between the switch and Radius server, console access to the switch in real time, we can see the output, and then also the live logging in ICE. By having information captured, even though you're not having an issue, is very good foundation. So let's say 2 years from now you have any issues, you have very good evidence. In any case, thank you for watching this video. Hopefully this helps you. Thank you.